Hello guys, welcome back to my channel. Today we're going to be looking at question 9 and 10 on a January CXC Mathematics 2022 resit past paper. Let's get right into it. It says the diagram below shows a circle with points P, Q, R and S. And while you're reading the question, you can look at the circle just to make sure you see what's going on. Alright, line on the circumference and its center is marked O. We can see it right there. RP is the diameter of the circle, so that's RP. And AB is a tangent to the circle at point P, right here. Okay, we have that information. Angle APQ is 3x. So we have APQ, that's 3x over there. Angle QPR, we're looking for QPR. Very important that we realize what's going on here. And angle RPS is equal to x degrees. So RPS is x. Angle QSP is 54 degrees. QSP. Alright, we're good to go. Now let's take this down a bit now. It says determine the value of each of the following angles, show detailed working where possible, and give a reason for your value. Alright, let's start with x. So first of all, I want x degrees, right? X is in a triangle. I don't have enough information in that triangle to find it, but I know that OP is a radius. Now, and AB is a tangent. Now what is very important, note, is that the radius actually forms a 90-degree angle with a tangent at a given point. So all of this angle right around here is 90, meaning that my 2x and my 3x degrees will combine to give me a 90 degree. So I'm going to say that 2x plus 3x is equal to 90 degrees. Now it's very important that you know that circle theorem, when doing circle theorem questions, we don't always use completed circle theorems. There are a few basic concepts that we can use. This will be 5x equal to 90, and I divide both sides by 5, so x would be equal to 18 degrees. Alright, so you can put that in because information will come in handy. This is 18, 2 times 18, this will be 36, 3 times 18 will be 54. I'm just putting them there because I know I'm going to use them. Now of course they're going to ask you, what is the reason? And we know that the radius forms a 90-degree angle with a tangent at a given point. So I would have typed this here already. The radius forms a 90-degree angle with a tangent at a given point. As you can see, that is how we were able to find the angle right here. Alright, let's go to the next page. The next page is asking us for y and the reason. So let's go back to the previous page. Now look at angle y. Angle y is right up here. But there's something also very unique about this triangle right here. If you note that this triangle right here actually is formed in a semicircle. And whenever a triangle is formed in a semicircle, then the angle over here would be, which is opposite the hypotenuse right here, would be a 90-degree angle, right? This is a triangle formed in a semicircle. So you're going to have a 90-degree angle here being formed at the arc or at the circumference. Alright? So let's go. So if this is 90, now here, this is such a good question because there are so many different ways to work different questions. If this is 90 and over this side is 54, then of course we can find the smaller side, which is over here. Alright, and we can say, what we're going to say is that this will be 90 minus 54. That is going to give me 36 degrees. Good, so I know that this is 36. Now if this is 36 and this is y and this is 18, how do I find y? All the angles in a triangle add up to 180 degrees. So I know that I can find y by simply adding 18 and this angle over here and subtracting it from 180. I didn't even need to find a small angle, you know, because guess what? This entire angle is 90 degrees. Alright, so it's 90, 18, and y would give me 180. So I don't really need a small angle. I might need it for a different question, but at this point I don't even need that. I didn't need to do that calculation in here at all. So let's go back to the page now. So we can say y is equal to 180 degrees minus previous. 180 degrees minus 90 degrees. Plus, let's just go back and just make sure we have all the right angles here. So that this triangle right here, as you can see, the angles would be 18. This would be 90 because of the angle formed at the circumference in the semicircle. And of course, you have y here, and the sum of the angles in a triangle add up to 180 degrees. So let's go back. So it's 180 minus 90 plus 18. So y is equal to, and here's a chance for you to bring in your calculator. You don't even have to do much work here. So 180, you subtract, you put a bracket in there because you need 90 to be added to 18 first before it subtract from 180. So that's 72 degrees. So y is 72 degrees. Now, what are the reasons? So we have angle formed in a semicircle. Alright, so that angle was equal to 90 degrees as we showed you before. And we also have, that's one reason. The second reason is that the angles in a triangle add up to 180. Alright, so angles in a triangle add up to 180 degrees. And you'll be done there. Now, whenever you do a question, you can always go back and put in your angle because you never know when you might use it. So I know that this right here is 72 degrees. Alright? Right. Let's go back. Now the next question they want from us is that they want z, angle z, and the reason for angle z. Now this is a pretty good circuit theorem question. Nothing for you to kill yourself about. You don't even need that much circuit theorem in this question. Because guess what now? If I'm going to find z, two things we can establish. Alright? Let us ignore circuit theorem. This is a triangle right here. This is a triangle. We know two angles in the triangle. So finding the third angle is not a problem. This is 54. This here is 3x, which is 1836. So all I need to do is try to find z, because I know over here is already 54, so technically you don't even have a problem. So let's say we wanted to use angles in a triangle. I'm just writing it here because you can see the diagram at the same point. I'm referring to question, to part 3 here. So that's the question on the next page that I'm doing here. And I'm trying to find z. So z would simply be equal to 180 because angles in a triangle add up to 180 minus the angles that we have there already, which is 54 plus 36 plus 18. So z is equal to 180 minus, alright, again, you don't have to worry your brain because you have your calculator right here. Alright, let me just go in. So that's 180 minus 54 plus 18 plus 36. That's equal to, well, 54. Let me put in the angles. 54, 36, and 18. And z is equal to 72 degrees. Now, if I'm doing it this way, I would say angles in a triangle would add up to 180. Alright? However, we can also use circuit theorem and note this now. Let me just clean it up so you can see it properly. We also have, notice if I'm going to use circuit theorem, we have angles subtended by the same arc, or angles standing on the same arc. Notice clearly, or on the same card, notice clearly that both of these angles right here are standing on the same point right here on the circumference, same card, same arc, as you can see right here. So these two angles would actually be equal. So y is actually equal to z. Now if I use the circuit theorem, then it would prevent me from doing all that work that I did there. I'm just stating that what? The angles form from the same point on the circumference standing on the same card. Alright? Those two angles would be equal. So y would be equal to z. And that's it. But the point of me doing it this way is to show you that we don't always need circuit theorem. You have triangles in there, angles in a triangle up to 180. All of those are concepts that we can use. So sometimes it might look complex, but you can just use your knowledge of how triangles work, how quadrilateral work, and you can work out the angles that you need. Alright, let's go to the next page. Alright, and that would have been the reason for working this part. So whichever method you choose. Alright, let's go to the next question. And this is question B. It says the diagram below shows straight roads connecting towns L, M, N, and R. Alright, and we have that LR equal to 18 kilometers. So LR is 18 kilometers, LN is 12 kilometers, and MN is 10 kilometers. As you can see there, angle RLN is equal to 25 degrees. We can see that there, and angle LMN is equal to 88 degrees, as we can see right here. Now, the first question is to calculate angle MLN. Okay, so let's look for it. M is right here, L is right here, and N is right here. So this is the angle that we want. Now the question is, what technique am I going to use to work this angle out? All you have to do is look at the information that you actually have. We know one angle already. We know this side. We have two sides. We have one angle. We need the next angle. Now, of course, that is telling me that I'm going to have to be using the sine rule here. Alright? And how do we differentiate between the sine rule and the cosine rule? Normally, I would probably need to find the next side with the information that I have. So I would use the cosine rule there when I have three sides involved on one angle. So it depends on the knowledge that you have. You're going to have to involve two angles because you're trying to find an angle. You already have an next angle, you have two sides. So that is how we know we need to use the sine rule. Alright, so let us call this theta, for example. Now we can say sine theta over the side that is opposite to this angle, which is 10 kilometers, over 10 is equal to, alright, the angle that we know, which is 88, the sine of it, sine 88, over the side opposite the 88 angle, which is 12. Alright, this now just becomes a matter of working out. Alright, so we can even go ahead and we find sine theta by multiplying both sides by 10. So we get rid of the 10 from over here because theta is over there. This would cancel out. So sine theta is equal to all of this. And guess what? I don't want to put all that inside of my calculator, so I get one answer. So I'm going to have my fraction bar. I'm going to say sine. The bracket is open, so I'm going to close it. 88 all over 12. I go to the side. And I'm going to have multiplied by 10 equal. I have 0.833. So 0.833. So to get theta, alright, let me get some space here. I'm going to have to get rid of a sine, which I use a sine inverse of 0.833. So let's pull up my calculator here. So on shift sine inverse, so that's how we get the sine inverse, shift, right? 0.833, you close the bracket, you press equal. That's 56.4 degrees. 56.4 degrees. Do not leave off the degree sign. Now let me go back up. So I'm going to write there, I'm going to put on the 56.4 degrees. Alright, we're good there. Calculate the distance NR. Alright, where is NR? Alright, NR is this distance over here. I want this distance. Now let's look at it. We have this triangle down here. So this is not a bad question at all. Helping you to realize when you need to use what. Now I have an angle here. I have the two sides that are adjacent to the angle and I need the next side. Obviously in this case, I cannot use the sine rule. That's going to have to be the cosine rule. Alright. So the cosine rule, and I'm going to call the side that I want to find C, would say that C squared equal A squared plus B squared minus 2AB cos theta. Good. So let's go back up for A, B, and C so you understand the formula. A, B, and C represents the angles adjacent to the angle, the sides adjacent to the angle. It doesn't matter which one you call A or B. The angle, which is big C, is the angle right there. Alright? So the side opposite is small c. That's all we need. So we're going to plug that in now and see what happens. So we have 12, 18, and the angle is 25. Let's go down. So c squared equal 18 squared plus 12 squared minus 2 times 18 times 12 cosine 25 degrees. And guess what? You can put all this inside of your calculator. So let's clear this. So I'm going to have 18 squared plus 12 squared minus 2 times 12 times 18 cosine of 25 degrees equal. That's 76.48. So c squared equal to 76.48. Alright, let's get the square root of that. So I'm going to have to square root both sides anyways. Square root of both sides. So c equal, alright, on the square root of 76.48 equal. And that's 8.7. So you're going to have this as 8.7 kilometers. Alright, let's take this down and see what else they want from us. Nothing? Alright, let's go to the next page. Let me go back up so you can see the diagram. I'm going to the next page. Now the next page says determine the bearing of tone R from tone L. Alright, previous. R from L. So the north sign is here. Now this is pretty straightforward because the bearing of R from L is measured from north. So let me use a different color here. This would be the bearing right here. All of this angle. Because we're taking R from L and we measure it from the north sign. So it's at 50 degrees, 56.4 degrees, and 25 degrees. All I have to do is add up all that and it's going to tell me where R is with respect to L. So R from L. Alright, so 50, 56.4, and 25. Let's go. So this would be 50 plus 56.4 plus 25. Alright, once again, we can put all that inside of the calculator. So on 50 plus 56.4 plus 25. Alright, why do I have 28 there? It should be 25. That's equal to 131.4. So that's 131.4 degrees. Alright, or 131.4 degrees. That is the bearing. This turns out to be easy this time because the angles you'd have found going around. And that's there you have your 12 marks. Now let's go to the next page now. Alright, here we go. It said the points O, P, and R are shown on the grid below. And we can see all O, P, and R. Write the position vector of R. Now position vector, as you know, it would be the vector taken away from the origin. Alright, that's normally how we get the position vector. We look at the vector with respect to the origin. So if I want the vector OR, I'm looking from O to R. And we can even go ahead and sketch the vector. Let me just do it here. From O to R. Alright, so that's the vector there. Now, vectors deal with horizontal and vertical movement. So all I have to do is to count the horizontal movement and then count the vertical movement from the origin. So we have 1, 2, 3, 4, 5. So this is going to be 5 here. Let me go again. 1, 2, 3, 4, 5. And I'm going 1 up. 5, 1. Now notice that position vectors can easily be found by taking the coordinate. Because by counting all the position vector with respect to the origin, the coordinates are also written with respect to the origin. So either way works. Alright, let's go down. Another point Q is located in a way such that QP is equal to 2, negative 4. Alright, so we know that QP is 2, negative 4. Using information, plot the point Q on the diagram. So I know what, sorry, not QP, QR. QR is 2, negative 4. I do not know what point Q is, but I know what point R is. So guess what? I am going to turn this around. Since I know what R is, because R is on the diagram, I'm going to turn it around and go from R to Q by counting off. Now, if I have QR, RQ is just a negative vector of QR. So it's going to be negative 2. This is negative already 4. So if I count negative 2, 4, it takes me right to Q from R, of course. So let's go back up. I'm going to find R. So now, what does negative 2 means? Negative 2 means 2 to the left from R. So 1, 2, and then 4 means you go 4 up. 1, 2, 3, 4. right here. So here's where Q is going to be. Now QR, I can actually go right ahead and draw the vector right here from Q. Oh, Control Z. Let me get this neatly from Q to R. There we go. Now let's check it to see if it's actually the same. QR is 2, negative 4. So let's go from Q to R. 2. So 2 to the right. 1, 2. Then negative 4. 1, 2, 3, 4 down. That's it. So you have Q on the graph. Alright, do we have any more questions on this page? No, but let me bring the graph back up because we might be using the information, right? Let's go to the next page. Determine the modulus, which is the length of QR, and the magnitude of QR. So the modulus sign around those two lines means the magnitude or the size, or however you want to see it. So let's start with QR. QR, as we know it, is equal to, let's go to the previous page. QR is equal to 2, negative 4. Now the magnitude of a vector is actually formed, done similar to how you use Pythagoras' theorem. So the modulus of QR is equal to the square root of the horizontal movement squared, which is 2 squared, plus the vertical movement, which is negative 4 squared. Ensure you put the negative 4 in a bracket. That's going to give me, and if you work this out, 4 plus 16. So it's a square root, I'm going to put that there, of 4 plus 16, which is the square root of 20. Now the square root, let's bring up our calculators here. Square root of 20, square root of 20 equal 2 root 5. Sometimes they would do something like this, alright? So it's still good to know it. But let's put it 4.47. So that's 4.47 units. Alright, show by calculation that OPQR is a parallelogram. Alright, let's go back on the diagram. Previous. So we want to show that OPQR. Now note what a parallelogram is. Opposite sides are equal and opposite sides are parallel. So that's OPQ. So let me draw a straight line. Alright, good. Now if this is a parallelogram, then opposite sides are equal and opposite sides are parallel. Good. So I can go right ahead to show that the opposite sides are parallel. Now the sides that are opposite now are QR and PO, depending on how you want to look at it. Alright, so QR and PO. Now we know that QR, we know QR already. QR is 2, negative 4. PO is also 2, negative 4. Alright, let's go to the next page. So we're looking at PO and we're looking at QR. Now PO is equal to 2, negative 4. QR is equal to 2, negative 4. So right away we have it here that opposite sides are parallel and equal. Now of course, if we have that both sides are the same vector, then there's no need to find the modulus because the modulus will be the same. Mod PQ would naturally be the mod of QR, as PQ is equal to QR. So that's one pair of sides. Now let's look at the other two set of sides previous. Also means that PQ and OR are also parallel and equal. Alright? And we can count them off. PQ. From a diagram we're going to have 1, 2, 3, 4, 5. 5, 1. So PQ is 5, 1. Alright, if we go OR, 1, 2, 3, 4, 5, 5, 1. Alright, so let's go back. PQ, OR. Also, PQ equal to OR. which is equal to 5, 1. Alright, there's no need to worry about the modulus because we already know that the vectors are the same based on how we write them. Hence, they are parallel and they have the same magnitude. Alright, once they are equal, they are parallel and they have the same magnitude. And of course, I can simply, because I'm reading the information from the diagram, I could start by saying from the diagram. So they know that I'm actually reading off the information of the diagram because I completed the quadrilateral or the parallelogram in the side. So we have the opposite sides being equal. The mere fact that they turn out to be the same value, they're also parallel, depending on the angle that you take it from. So once we have shown it on the diagram, so that's why I'm saying from the diagram, and we have read from the diagram to get that both of them are equal. So I need not to do anything else. Alright? Just write my statement and there it is. Alright. Here we go down to a matrix C's question now. It says calculate the value of x and the value of y in the matrix equation below. Alright, now you know how equations work. Just like when you're doing regular maths. You have brackets, you're going to have to expand your brackets before you can do anything else. Technically, this is a matrix, but the same concept does apply. Alright? So, I could start by expanding my brackets. So, you know how it goes. It's row times column. So, let me just open my big one here. So, it's going to be 1 times negative 4 plus 5 times 2. Put in a sign carefully so you can see it. You skip a space and you go row 1 again times column 2. So, it's 1 times 1 plus 5 times 9. Alright, you move to row 2 and you do the same thing. It's 2 times negative 4 plus y times 2. Then row 2 again times column 2 over here now, which is going to be 2 times 1 plus y times 9. And this is equal to x 46, 6, 65. Alright, let's tidy this up. In my first, 1 times negative 4 is going to give me negative 4 plus 10. And of course, negative 4 plus 10 is going to give me 6. Down here, I'm going to have, well, let me work with the row first. 1 times 1, that's 1. 5 times 9 is 45. 45 plus 1 is going to give me 46. Alright, down here now. 2 times negative 4 is negative 8 plus 2y. Alright, so you just put that plus 2y there. Now remember, you have to do multiplication before addition. That is important. Then you have 2 times 1 here plus y times 9. Alright, so 2 times 1 plus y times 9. So it's going to be 2 plus y times 9 is 9y. And this is equal to x 46, 6, 65. Now the concept with matrix is that when two matrices are equal, the things in the same position are equal. So 6 is in the same position as x. X is equal to 6. Now let's work with the y thing now. You can have negative 8 plus 2y equal to 6 because they're in the same position. So these two are in the same position. Or I could work with the 2 plus 9y and the 65 because they're in the same position. Why not work with a simpler number? Okay? So negative 8 plus 2y is equal to 6. Bring over the 8 because it's negative, so 2y equal to 6 plus 8. Alright, 2y equal to 14. We divide both sides by 2. So y is equal to 7. And we're done with the question. That's it. Alright, next. Alright, now this question says now a transformation T represented by the matrix 0, 1, 1, 0 maps S onto S prime 5, 2. Describe the single transformation T. Now, I want you to realize something. This is the x value. This is the y value. Over here, the y value became the x value and the x value became the y value. So it's like a switch. So technically, do I have to recognize this matrix at point? No. Y becomes the x value and x becomes the y value. So in my brain, I know that this is a reflection in the line y equal x. Y equal x because the x value becomes the y value and the y value becomes the x value. So it's like a switch. Y becomes x, x becomes y. So that is how we know it's a reflection in the line y equal to x. a good way to remember it, right? So even without knowing the matrix, you know exactly what had happened. Alright, thank you. And that's the end of the paper. I would have done. Now please, we have all the questions work from question 1 all the way up to the final question, which is this question right here. So you can watch